Hello again. Today we are going to deal with ballistics 2 dimensions. So let's start, write a quick review with the formulas that we're going to use, and let's start. Okay. This is the first equation, second equation, third equation, and fourth equation. Okay, and I remind you, when it's constant velocity, V const. Okay, didn't forget anything. Okay, now let's talk about 2 dimensions ballistics, kinematics. Suppose we throw a ball horizontally. Let's start with horizontally. So just suppose I have this tower, and from this height, let's say, I don't know, 80 meters, I throw horizontally with the velocity of, let's say, 20 meters per second, an object. Obviously, we all know that this object will go in this path, like that, something like that, and it will reach the ground. And I want to know everything. I want to know how long did it take it to reach the ground, how far did it reach, what is the velocity when it reaches the ground. Obviously, it's going to be with a certain angle here. I want to know everything. How do I deal with these kind of problems? The main idea is we divide it in our head into 2 separate motions. We separate it into the Y motion and the X motion, and then we combine them together, and I'll show you how to do it. Let's define the origin here for the X and the Y. So let's define this is positive for the Y-axis, positive for the X-axis, and this is the origin for both of them. So, how do I deal with it? First of all, I write the data for the X-axis and the Y-axis. Let's start with the X-axis. We know that the ball is going, forget that it goes down, just imagine it goes only to the right. There are no forces on the ball because the forces is only downwards, mg of course. So if it doesn't have any forces applied on it, it means that the velocity will be constant according to the first law of Newton. So I only need to write these 4 variables. x0 is 0, x final I don't know. Velocity is always 20 because it doesn't change it. If there is no forces on it, the velocity in the x-axis remains 20. And time I don't know. Let's go now to the y-axis. Obviously it accelerates downwards as we know. So I'll write all the 6 variables. V final, time, and A. Okay, let's start. Y0 is 0. It started here in the origin. It finishes 80 plus 80 because this is the positive axis, and so the numbers increase that way. V0, okay, the V initial is 0. Why? Because the velocity is only with the x-axis. In this direction it has no velocity, so the velocity, initial velocity is 0. Final velocity when it reaches the ground, I don't know. Just imagine it goes only this way, forget that it goes that way. We don't know what velocity is going to reach the ground. Time, I don't know. Acceleration, I do know. In the y-axis, it accelerates with g. G is always downwards, so it's positive, so it's plus g, or 10 meters per second squared. Now I have enough data in the y-axis, so I can find everything. Let's find both v final and time. Let's start with the time. I'll choose the third equation. Only instead of x, I'll write the y. Y equals to y0 plus v0. E plus a Okay, let's write. So y is 80 equals to 0 plus 10 t squared over 2. 80 equals to 5t squared. T squared is 16. T is 4 seconds. I know it's 4 seconds. Takes it to reach the ground. Now I can find the final velocity with this equation. Okay, let's put some numbers here. V final equals to V0 is 0, 10, 4, 40. So it's 40. It reaches the ground with a velocity of 40. Now, how do I combine them? The main idea is the time. This what combines both axes. The time it went down is the exact time it went horizontally in the x-axis. So if it took it 4 seconds to go downwards, it will take it also 4 seconds to go in this direction. And now I can find everything I want, the x. Now, it's very interesting because, look, the time it doesn't depend on the velocity I threw it. It means that even if I throw it at 500 meters per second, or at 1 meter per second, or at 0 meter per second, it doesn't matter, it will reach the ground the same time. In other words, if I drop a pen and another pen, I throw it horizontally, from the same height of course, they will both reach the ground at the same time. If you want something more extreme, if I drop this pen downwards and from this direction I shoot a bullet from a gun, horizontally of course, the bullet and the pen will reach the ground at the same time. Very interesting. Okay, because the time I got it from the y-axis, it doesn't matter the horizontal velocity. Okay, let's find the x. It's constant velocity, so I write this equation and I put numbers. X equals to 0 plus v is 24. X equals to 80 meters. 80. So now I know almost everything. I know it will take it 80 meters to go. The range of the throwing will be 80 meters. I know the velocity in the y-axis will be, what did I get? 40. And the velocity in the x-axis will be 20. But the ball, which I threw, it doesn't have x and y velocity. It only has one velocity, and the velocity is this. So what I need to do, if I know in the x-axis I have 20 and the y-axis I have 40, I need to find the resultant velocity, or the total velocity. So it must be somewhere here, as we see there, and the alpha is always with the x-axis. If we want to find the v, I remind you, it's square root of 20 squared plus 40 squared. And if I want to find the angle, tangent alpha is always the y over the x, 40 over 20. And that's it. That's how I find the v and the alpha. The v will be 20 squared plus 40 squared, square root 44.52, and the angle will be shift tangent 2, shift tangent 2, 63.43 degrees. Okay, now I know everything about this ball. And this is two-dimensional because we deal with the x and the y simultaneously. And the t, this is the main issue, the time combines them together. This is what makes it possible to work with both axes. Okay, we'll do a lot of examples, so let's start. Okay, I'll give you the main idea of these problems, the main questions that are usually asked in this kind of questions. Okay, so let's do this one. There's a plane here. I don't know how to draw a plane. Plane. A plane. And it has a certain velocity. I don't know what's the velocity. And once it reaches, let's say 2 kilometers, it sees a target here. The target here, let's say it's around 3 kilometers ahead. And the plane wants to bomb this target, okay? Target. So what it does, when it reaches exactly this point, it wants to release a bomb which will reach the target. Now the main idea is that when you release an object from the plane, from a train, from a car, it doesn't matter, the object will get the velocity of the plane. So if it drops a bomb, and I'm not talking about a laser guided bomb or missiles or, with engines, I'm just talking releasing a bomb, the bomb will get the velocity of the plane. So the velocity of the plane and the velocity of the bomb are exactly the same. So I can write here bomb. It's exactly the same. So the bomb will have a certain velocity, and I want to know what velocity the plane must have, or the bomb must have, in order for it to reach the target. And then I want to know what velocity it's going to reach it, and what angle it's going to reach it, and everything. So you saw this kind of problems maybe in old war movies when a plane, not missile-guided bombs, but simple bombs, you saw the planes open their hatches and then many bombs fell and supposed to reach the target. Why many bombs? Because this calculation is not, it theoretically is exact, but practically there's a wind, there's all kind of diversions, I don't know. So if you throw a few bombs or many bombs, maybe one of them will reach the target exactly. Okay, but theoretically it should do the trick. So let's do exactly the same as we did before. In the x-axis, the velocity is constant because the force is here, not there. So I write only these 4. In the y-axis, obviously the mg is going to apply there, so it will accelerate. I need all 6. Okay, let's start, see what we have. Let's say this is the origin now, okay? It doesn't matter which way you define the origin, which place, just define it and define the positive axis. Let's say this is the positive in the y-axis, this is the positive in the x-axis, okay? You must define it before you start the exercise. Okay, let's start with the x. x0 is 0 because it started here. Forget it goes down, just imagine it goes like that, from here to there. So it starts here. X final I know in 3 kilometers, which is 3,000 meters. Remember, we work with meters. V I don't know, this is what I'm asked to find out. Time I don't know either. Okay. Y. It started, Y0 is here, so it will be 2,000 kilometers. Sorry, 2,000 meters. Y final will be 0 when it reaches the target. V final, V initial, V0, it's the velocity in the y direction, which is 0. V final, I don't know when it's going, what velocity it's going to reach the target. Acceleration is, pay attention, it's downwards 10, but this is the positive axis, so it's minus 10. And time I don't know. But I can find everything I want from this data because I have enough to solve it. Let's find first the time with this formula. So y equals to y0 plus v0 plus 80 squared over 2. Let's put numbers. 0 equal to 2,000 plus 0 minus 5t squared. So I lost it. 400 equals to 2 squared, 2 equals 20 seconds. Great, I have beautiful numbers. Lucky me. Okay, so t is 20. I have a calculator just to make sure. It's strange that it's so nice numbers. Okay, let's find the V final. I want to know everything. So V final, Vt plus AT. So V final is, I want to find it, 0 minus 10 times 20, which is minus 200. Why minus 200? Minus 200, it means that the velocity is in the opposite direction of the positive, which is exactly what happens here, because the velocity is downwards and the positive direction is upwards. So I expect it to be minus. Okay, now again, this is the main idea of these problems. If it took it 20 seconds to go down, it will take 20 seconds to go to the right. So I know that the time is 20, now I can find the velocity with this formula, because it's constant velocity. So 3000 equals to 0 plus V multiplied by 20, so V is 150 meters per second. 150. Okay, if I want to find it in kilometers per hour, if you want, you can multiply it by 3.6. You will get it in kilometers per hour. Multiply by 3.6. It's 540 kilometers per hour. Okay, just a minute. Great. So what happens in the tower or in the, I don't know, they tell the pilot when it reaches 2 kilometers above the ground and it sees the target 3 kilometers ahead, it should be in the velocity of 150 and exactly drop the bomb. And if it does so, it should hit the target. Usually they drop few bombs because, again, there are many things that influence the bomb, like wind. It doesn't open it exactly the same time. One bomb didn't even went out, didn't explode, I don't know. Okay, so this is why you see a lot of bombs in the movies. Okay, I want to know at what angle it reaches the target. So when it reaches the target, here, it has 150 velocity in the x-axis. We found that it has minus 200, which is 200 velocity in this direction. So the velocity, the real velocity, it has the resultant velocity will be in this magnitude with this angle. So if I want to find the angle, I'll do 200 over 150 and I'll find the angle. So it's 200 over 150, shift tangent, 53.13 degrees, and if I want to find the velocity, this is how I find the velocity, okay? So it will be 150 squared plus 200 squared. Really? Again, very beautiful numbers. Very nice for me. Okay, so now I know everything about this exercise. Again, one more. Okay, now I want to prove that when I throw something horizontally with, let's do it only with letters, with parameters, from the height of h, I want to prove that the path in which this ball is moving, we know it's like that, but I want to prove that it is a part of a parabola, okay? How do I prove it? I want to find an equations that shows me this path. Let's say this is the origin. This is the positive way for the y-axis. This is the positive way for the x-axis. So my purpose is to find y equals to some function of x. In other words, I want to know, if I know where the x is, I know to know where the y is. Y is the height, x is the range it moved. So if the range is, for example, this range, I want to know what height it is. If the range is here, I want to know what height it is. I want to find the height as the function of the range, okay? Height is the y, this is why I chose this is the positive and this is the origin, because the y I get is exactly the height and the x will be the range. So what do I do? Again, the same idea. Let's write everything we know about this ball. Okay, x0, obviously it started with this 0. X, I'll leave it with x. I don't need the final x. I want, when I place an x, I want to know what the y will be. So x is x. V is v. With letters we'll do it. And t, I don't know. Y0, it started here with h. Y final, I don't know, it's y. I call it y because when, for example, it reaches this place, it did some x, and the height will be a certain y. V0 is 0 because in the y-axis it didn't have any velocity. V final here, I don't know. Acceleration is this direction, it's minus g. When we write a problem with letters, we don't write 10, we just leave it with g. Time I don't know. Now the main idea, again, the time it moved in the y direction is exactly the time it will move in the x direction. So let's find the time here and combine them. So from the x, I can write x equals to 0 plus v multiplied by t. In other words, this is the equation for the x. Let's write an equation for the y. Let's choose the third one. 0t. Okay, so y equals to h plus 0 minus g t squared over 2. So y will be h minus g t squared over 2. Now I remind you our purpose. We want to find the y as the function of x, not the function of t. So the idea is that the t we combine this equation with the t. I isolate t from here, which will be x over v, and put it here. So I'll get y equals to h minus g over 2 multiplied by t squared, which is x squared over v squared. Now look what I found. I'll write it again in another way. I'll write it like this. Minus g 2v squared multiplied by x squared plus h. Look, this is constant because g is always constant, 2 obviously. V is the velocity is constant. The v is constant because it will be given obviously in the exercise. Okay, so this is constant, so I'll get y equals to, let's call it a x squared, h obviously it's constant because it's the initial height, plus b. This is exactly the equation of a parabola, and now I proved that the path which the ball is moving upon is a parabola. If I want to draw the parabola, it's a crime parabola because the a is negative, like that. When x is 0, y is h, it starts with here, 0 plus h. If I want to find this, I need to put 0 with the y. It doesn't really matter, but this parabola is in crime mode, so it will be like that. And now I proved that the path is a parabola. This is the equation, and this is the graph. Okay, so it's another way to show you how I deal with these kind of problems. Okay, let's move to more exercises. Let's throw a ball with an angle now. Okay, so suppose I have, this is the ground, and this is a tower, h equals to, again, 80 meters, and I throw a ball with a velocity, initial velocity of, let's say, 50 meters per second, with an angle, alpha, 53.13 degrees. And I want to know again everything. So how do I deal with this kind of problem? First of all, obviously we know that the path will be something like that. obviously, which is also a parabola. We'll prove it later, maybe. How do I treat these kind of problems? Again, exactly the same. First of all, I separate the velocity into the x-axis and the y-axis. I remind you that this one will get the cosine. So this will be 50 cosine 53.13, which is 30. And this will be 50 sine 53.13, which is obviously 40 because it's a 30 is, okay, if you know it's good, if you don't know it's also good, because 30, 40 and 50 are Pythagorean numbers. 3 squared plus 4 squared equal to 5 squared. If you know it, so it's nice. Anyway, again, let's choose an origin and work with it. Let's say this is the origin, this is the plus for the y, this is the plus for the x, and again I separate it into the x and the y. Okay, let's start with the x. The x is 30 and it will remain 30. Why it will remain 30? Because there is no forces on it. The forces is only in the y direction. So I only write these 4 variables. In the y, obviously the mg is working, so it will accelerate and we have all 6. Okay. Usually we ask 2 questions in these kind of problems. First question will be the maximum height it will reach, h max. And the other question we usually ask is this, the range, the angle of the velocity. So we want to know everything about when it reaches the top and everything when it reaches the ground. Let's start with the top. Max height. Okay, so let's see what we know. x0 is 0. X, I don't know. V, it will be always 30. Time, I have no idea. Y0, it started here at the height of 80. Y final, I don't know. It's the maximum height. This is what I want to know. V initial, I do know. It's 40 with the positive direction. So it's 40. V final, I do know. Because in the y-axis, when it reaches the top, when it reaches the final height, it will stop in the y-axis. In the x-axis, it will remain 30. So when it reaches the top, the velocity will be only 30 in this direction, no velocity in this direction. So V final is 0. A is minus g, minus 10. Because this is the positive and the acceleration is this way. Okay, I have enough data here, I can find everything. Let's find also the time, also the y. So I'll choose the second equation. Vt equals to V0 plus AT. So V final equals to, 0 equals to 40 minus 10t, t equals to 4 seconds. It will take it 4 seconds to reach the top, from here to there. Let's see the y. Let's choose the first equation because we have enough data for it. So y equals to y0 is 80, v0 is 40 plus 0 over 2 multiplied by 4. Y max will be 80 plus 20 multiplied by 4. 160 meters. Okay, so the initial height is 160. It means that it went 80 more to the top. If I want, let's find it, okay? I know it will take it also 4 seconds to go in this direction. So we can find the range it made in order to reach this position. So I'll choose, obviously, this equation because it's constant velocity. 30 multiplied by 4, 120 meters. So now I know that this is 120 meters and this is 160 meters. Now this was the first question I can ask about the maximum height. Now let's ask about this position, this point, when it reaches the ground. So I need to write again all the data from the beginning, x and y. x0, x, v, t, y0, y, v0, vt, a, t. Okay, now I want to know about reaching the ground, okay? There, when it reaches here. So let's start again. x0 is 0, it started from here. Velocity is 30. Sorry, velocity is 30. The range I don't know. I do know it's more than 120, but I don't know. The time, obviously I don't know from here to there, but obviously it will be more than 4 seconds. Okay, why? It started with 80. It will finish with 0, because when it reaches the ground, I remind you, when we work with y, we don't have to divide it into the up to the top and then back to the ground. We can choose all this path as one path. We don't have to divide it into 2 parts because the acceleration is constant. I remind you, when the acceleration is constant, it doesn't change. The velocity obviously changed, but the acceleration is always downwards. We can treat it as one path. V0 is 40, this direction, positive direction. V final, I don't know the final velocity. A is always minus 10, even though it changes direction. The minus 10 does 2 things. It slows it down in the positive direction, and then it accelerates it in the negative direction. Acceleration in the negative direction is also minus. So A is always, if this is the positive direction, A will be always this direction minus. It functions in 2 roles. It slows it down and then it accelerates it in the opposite direction, but it's still minus 10. And time I don't know. Okay, now I have enough data to calculate here. Let's choose the third equation. So 0 equals to 80 plus 40t minus 5t squared. Okay, t equals 2. I remind you, we have mode 5.3, if you don't remember what I was talking about. Mode 5.3 solves us these quadratic equations. Minus 5, 40, 80. Not lucky today now, because the numbers are not so nice. 9.656, okay, 6, doesn't matter. And this is negative, it doesn't matter. Okay, now I know the time. It will take it 9.66 seconds to reach the ground. Now, if I want, I can find the final velocity. If I want. If I don't, then never mind. But I do want, I do know that the time in the x-axis will be exactly the same. So now I can find the range. So it's x equals to x0 plus vt, which x equals to 0 plus 30 multiplied by 966, x equal to, so mode 1 is to get out from the mode 5.3. 30 multiplied by 966, it's around 289.8, something like that. Okay. If I want to find the angle it reaches here, I remind you what we do. We take the x velocity, which is 30, it's constant. We find the y velocity, it's easy. We find the vt from here. We place it there. If it should be minus because this is the positive direction and this is the direction it reaches the ground. We write it with positive numbers. The minus just says that the direction is here. And then we calculate the resultant velocity and the angle if you want, exactly the same as we did before. Okay, more. Okay, let's prove now that let's show that when we throw a ball like that with an angle, it will take it to reach the ground. Just a minute. I'll just throw it. If we throw it from the ground in a certain velocity with a certain angle, let's prove that it's a symmetrical problem. So it means that if we look at the top and we look at this point, the time to reach here will be exactly the time to reach there. And we prove also, we show also that the velocity that it reaches the ground is exactly the same velocity that it started with. Let's put numbers now. Let's say this is 100 meters per second and the angle will be 30 degrees. Okay, so let's again find everything. I want to know the max height, h max. I want to know the range. I want to know the total range, and I want to find the final velocity. So again, let's start with the x and the y. In the x, again, x0, x, v, t. y0, y, a, v, t. Forgot something, v0, v final. Okay, I remind you, first of all, we separate the initial velocity into two velocities. This will get the cosine. 100 cosine 30 is 50 square root of 3. Okay? And 100 sine 30 is obviously 50. Okay, so now I'm going to deal with h max. H max. Again, x. Let's say this is the origin. This is the positive here, positive there. Okay, x0 is 0. X final I don't know. V is constant, which is 50 square root of 3. Time I don't know. Y0 is 0. Y final, this is the max height. This is what I want to find. A is minus 10 because the acceleration is in this direction. V0 is plus 50. Time I don't know. V final I do know. When it reaches the top with the y-axis, it stops. Okay, now I can find everything here. Let's find first of all the time. So V final equals to V0 plus AT. So I'll get V final is 0 equals to 50 minus 10t. T equals to 5. So it's 5 seconds to reach the top. Let's find the final height with this equation. Y equals to Y0 plus V0 plus V final divided 2 over t. So Y equals to 0 plus V0 is 50 plus 0 over 2 multiplied by 5. Y equals to something, right? 25, so it's 125 meters. 125 meters, I think. So H max is 125 meters. Okay, again, if it took it 5 seconds to go up, it will take it 5 seconds to move to the right. Let's find the x. So x equal to 0 plus 50 So x will be 250 250 square root of 3. So this is 250 square root of 3. Okay, this is dealing with the max height. We found everything. And I remind you again, the velocity here will be nothing in the y direction. In the x direction, it will remain with a velocity of 50 square root of 3. Now I want to know everything about this point. So again, let's write the data for this point. x0, xv, t, y0, y, v0, v final, a, t. So, let's start with the x. x0 is 0. X final, I don't know. I'll show you it will be exactly two times this will prove its symmetrical problem. V, it will remain always 50 square root of 3 because the forces are on this direction also, nothing in this direction. Time, I don't know. I'll prove it will be 10 seconds, exactly twice the amount to reach the top. Okay, y0 is 0. Y final is also 0 because with the y-axis it starts here and it finishes here. V0 is 50. V final, I don't know, I'll prove it will be 50 this direction because it's a symmetrical problem. A is minus 10, we talked about it. It's always minus 10. It has two roles. First of all, it slows it down in the positive direction and then it accelerates it in the negative direction. Time, I'll prove it will be 10 seconds. Okay, let's choose the third formula. Y equals to y0 plus v0t. Okay, so 0 equal to 0 plus 50t minus 5t squared. 0 equal to 5t, 10 minus t. So t is 0 or 10. We'll take the 10. 0 doesn't mean too much to us. It only means that when I started our stopwatch, it was here, but we knew it already. Okay, so 10. And this is also 10. And this is the method to work with these problems. When you find t in the y-axis, place it in the x-axis also. Because this is what combines these two axes. Okay, let's find now the v final. V final equals to v0 plus at. V final equals to 50 minus 10 multiplied by 10, which is minus 50. Minus 50 is good because it shows us that this is this direction and it's 50, exactly the same as it was in the beginning. Okay, let's find the x. X equals to x0 plus v multiplied by t. X equals to 0 plus 50, 500, like that. So all the x is 500 square root of 3, which is exactly twice. And so now we know it's a symmetrical problem. In the x-axis, the velocity is 50 square root of 3. In the y-axis, the velocity will be 50. So if we want to find the v, I have 50 square root of 3 and 50 here, and this is the resultant velocity. So the resultant velocity will be 50 square root of 3 squared plus 50 squared. It should be 100. You can check it. I'll check it for you. 50 square root of 3 squared plus 50 squared. I didn't put it with like that. Okay, square root is exactly 100. If we want to find the tangent, take the alpha. Y over x, 50 over 50 square root of 3. Alpha, so it's like 1 over square root of 3. If you know these are certain angles, it will be 30 degrees. So now we showed that exactly this path is symmetrical path. It's exactly a parabola, we'll prove it later. It's exactly a parabola, and this is the peak, and it's symmetrical. Okay, more. Okay, let's prove now it's a parabola. Okay, so again, no, I don't need this. Let's say I threw a ball from here at the velocity v under alpha. We know it goes like that. I want to prove that the path in which this ball is going is a parabola. In other words, I want to show that the y is a function of x. Y is the height, x is the range, and this is the origin. I want to find an equation that shows me the height as the function of the range, and to prove that this equation exactly matches this path, which is a parabola. So again, let's do exactly the same. x0, x, v, t, y, y0, y, a, v0, vt. Something is missing, t. Okay. First of all, we divide the situation into two axes. This velocity will get v cosine alpha in this direction, v sine alpha in this direction. Okay, x0 is obviously 0. X is x. I want to find x because I don't want only the final x. I want every x. For example, this x, this x. I want to find the y when I know the x. If I know the x, I want to know what the y is. This is finding an equation, y as a function of x. V is v cosine alpha. It's constant. Time, I don't know. V0 is 0. Y is y, because again, I don't want the final y, I want every y. I want to know y as a function of x. A, we don't write minus 10, we write minus g, because the a is always in this direction, and it's a letter with letters. When you work with letters, remain with letters. V initial is v sine alpha, positive, because it's in the positive direction. V final, I don't know, that's it. Now again, the time, what combines these two axes. Let's find the time from here. I'll get x equal to x0 plus v t, so x equal to 0 plus v cosine alpha t. So x equal to v cosine alpha t. This is what I know about the x-axis. Let's write about the y-axis. I'll choose the third equation. Okay, so y equals to 0 plus v